Some of you have joined us before, maybe both, all of you have joined us before, but welcome to the William M. Starco Planetarium at Parkland College. You're joining us for Winter Prairie Skies. Although I gotta say, over the course of this week, the temperatures and conditions have felt like a lot less like winter. So, but nevertheless, we still call it Winter Prairie Skies because that's the official season that we have here. As for me, my name is Erik Johnson. I'm the director of the Starco Planetarium. Despite what you see behind me with the Northern Lights, I am actually in my office at the planetarium, setting up a lovely green screen. And now I'm going to go ahead and spotlight for everybody else our planetarium producer, Waylena McCully. She is coming to us live from her home. That way we can both have our masks off while we share the night sky with all of you. Okay, and now the next thing that I'm going to be sharing is going to be, did you say that should I try the whole screen or should I just try the software for now?
Go ahead and try the whole screen. We'll see how that works out for us.
All right. Optimize screen sharing, what do you think?
Sure.
Okay, we'll try it that way. Okay, so I'm sharing a full screen with you all right now. That way I can toggle a little bit more deftly between various things that I want to show you tonight. At this time, I am trying to show you what you can find in the software known as Stellarium. Stellarium is the way that I've been sharing the night sky with my students for several years now in my astronomy classes. When we are in the planetarium dome, we usually use Digistar software, but when I'm here on my own computer, I tend to use this because I've just got so much experience with sharing it, and it's you know, set up pretty nicely for a single computer screen. Now you're looking at an image of the Starco Planetarium right now. It looks like a nice sunny green day, obviously a very different time of the year. We can actually show other landscapes through Stellarium. There are many preloaded landscapes, but we've added a couple of other features to this as well. You can see the facade of the Student Union of Parkland College. Once this loads up, there's one right there. And we also have one from the CUAS Observatory, the Prairie Winds Observatory. If you can read this very closely, you notice that the author is a familiar name. Waylena McCully actually used her 360-degree camera to take these panoramic photographs and gave me the guidance to help install this into my software so that I could share them with you during these shows. Out at the observatory, the reason why I set this up is because when you're out among the farmland, we have some nice flat horizons. So buildings and trees and whatnot don't get in the way when we're trying to observe the night sky. Okay, Waylena, have we actually put these skins up on the planetarium website yet? I don't remember if we did.
I don't know that we have. I think we share it through the astronomy club members somehow. But
oh yeah, we definitely did that. Yeah. Yeah.
So let's make a note that we should do that. I'll add that to the list.
Yeah, that's one of the many things we try to share with all of you. The virtual backgrounds that Waylena and I use, she's got one up right now. She made a lot of those, and we do have those as part of the resources available on our planetarium website. You can actually get a look at those right now because I can toggle to them. Let me see if I can pull this off correctly. So here is our planetarium website right there. And if I go to educational resources, and I'll just click resources for now, you can see a list of all sorts of fun things. Waylena set up lots of neat coloring pages and pages related to the Cosmic Quest shows that she ran last summer. There, the teleconferencing backgrounds. So you can get the same stuff in your backgrounds like what we have, what we tend to show you during our shows. Okay, lots of cool features in there. And I have a feeling that those chat comments that I've not read, Waylena has already shared the link with all of you. All right.
It's coming.
Okay, let me go back to Stellarium now. So obviously this is what we see during the daytime. I think what would be best is if I get us to the evening sky. Some of you who might have seen my posts on Facebook today, I had mentioned that this evening, right at about this moment, if you were to look outside under clear skies, you'd be able to see a chain of the Starlink satellites passing overhead. Unfortunately, from what I've seen, we've got some pretty cloudy skies tonight, so we are not going to be seeing any of those satellites this evening. The reason I knew that that was about to happen was because of another website that I love to share with all of you, heavensabove.com. You'll see up here on the upper right, I'll make this a little bigger for you all to look at. On the upper right, you can see that I've set up the location as our general latitude and longitude that we find here in Champaign. And what's amazing about this website is that you can click on all sorts of links here to find out when certain satellites would be passing overhead, including the Starlink satellites I was talking about, and also the International Space Station. And the space station right now is being seen before dawn, so I wouldn't recommend looking for it tonight unless you happen to be up really late this evening. But follow that link there in order to find out when the space station will be visible to all of you. Okay. Finding lots of fun tangents, aren't I? Oh, wow, it's already nighttime. Look at that. Let's find out how late I accidentally let it go. I'm going to do one thing here. Not that late. This is the skies at about 7:45 p.m. right here. And we are actually still looking in the west. I think the first thing I need to do to share with you how we know we're looking towards the west, there's a good cheap way to do it. That's turn on the cardinal directions. You've seen that in the planetarium, and you can see that here as well. I'm going to scroll up over here to this direction. I know that I'm looking north over here based off of what I see with the observatory, but there's some other really nice clues that you can see in this part of the sky. If you look over to the right here, you'll see a very familiar shape. Okay, feel free to tell us in the chat what you see when you see this group of stars. Actually, I'm going to go ahead and annotate because I don't want to give it away quite yet. I do this for a couple of reasons. One, I already said I don't want to give it away, but two, when I turn on certain lines of constellations, it will connect the dots with a few more stars than what I wanted to share with you. That's because this is an asterism in the sky and not the whole constellation. So, folks, perhaps you can tell me what you're seeing there in the chat. I see Waylena's comments there. I know that when we're in the dome, we show something looking like maybe a shopping cart. We might see a frying pan here. Perhaps you just see a spoon. That's what Big Bird always is telling me when we watch the One World, One Sky show. And then some people see it as a wagon, or they might see it as just a plow, okay? But here in North America, usually we refer to this as the Big Dipper because it's supposed to be kind of like a drinking gourd, like ladle, okay? Yeah, oh, Space Cat or Space Fox, that's a really neat one. And then Barbara mentioned Ursa Major. Excellent point with that one, Barbara. So what we're getting at with all of this is that you can see all sorts of different things when you look up at this part of the sky. Notice that the constellation known as Ursa Major covers a lot more stars, and Ursa Major comes from the Latin meaning big bear. Let me go ahead and remove the annotations because otherwise that's going to look pretty awkward here in a few moments. And now I'm going to scroll up here so you can see the whole entire bear right there. And now when you're looking at that bear, you see that the drawing looks pretty good in most respects, but I don't remember a bear having a golden retriever's tail on its rump like that. That's a little surprising and certainly anatomically incorrect. There are some mythological tales that explain why Ursa Major has such a long tail. I won't get into those right now. But I want to focus on the two pointer stars right here and here. When you draw a line with these two stars and go over to our left, we can find this star here, which is in actually the constellation Ursa Minor. And notice the pattern of the stars that you find in the little bear there. They look kind of like a little dipper. So this star, which we call Polaris, happens to lie within the Little Dipper, or within the constellation known as Ursa Minor. Polaris is called that because it is our pole star. It is the star that we see in the sky that's closest to the North Celestial Pole. If you take Earth's North Pole and extend that up into space, that point in the sky is very close to this star. So it's basically our pole star, hence the name Polaris. And because of its position above our North Pole, no matter where you're at in the Northern Hemisphere, if you see Polaris, you're going to see it very close to due north in the sky. So Polaris has been very useful for people for centuries because they could use that star as a reliable indicator of which way due north is. It's even more reliable than using Earth's magnetic field. So if you've ever used a compass, either the nice one with the little dial that turns and because it aligns with Earth's magnetic field, or the one on your phone, those have some little inaccuracies because of how Earth's magnetic field is not perfectly aligned with our rotation. But you can always rely upon the pole star to tell you which way is north. Okay, so there's the North Star right there. All right, let's look back over to the west because I saw something starting to get a little bit lower in the sky. Oh, it's still pretty high up there. You might notice a couple of interesting things right here in the center of my screen. I'm going to zoom in on them because I like how close they are this evening, and I want to check them out. So the two things I'm trying to point out to you, for one, is this neat little cluster of stars. When a lot of people look at this, I'm betting you're thinking it reminds you of the Big or the Little Dippers. A lot of people like to jokingly refer to this as the Tiny Dipper or the Micro Dipper right here. But what you're seeing right here, this is a nearby cluster of stars. They're actually all in the same place in space. And they are known as the Seven Sisters. Well, based on what you're seeing right now, do you only see 7 stars? Yeah, certainly not. The reason they're called the Seven Sisters is because you see maybe 5, 6, or 7 stars when you look at it with your own eyes. But if you're to take some binoculars or even point a telescope up at this part of the sky, you're going to see a lot more than 7 stars. In fact, this cluster actually has over 1,000 stars. I think it's about 1,500. And even though we call it the Seven Sisters, there's a nice technical name for it. And let me see if I can bring it up here. There we go. Ooh, that brought up a lot right there. Oh, I see. I know exactly what happened. We are looking at what we call the Pleiades. I know it's a bit of an awkward name to pronounce. You can try it for yourself right now. Pleiades, okay? But then there's another name that you see up there on the upper left that's probably a lot more familiar to you. Yeah, Subaru, or as the Japanese would pronounce it, Subaru, okay? They don't exactly say R's the same way we do, all right? So Subaru is the Japanese name for this cluster of stars, and the reason for that connection is because the car company actually named themselves after this star cluster. Okay, so my students, when they're trying to learn about identifying the Pleiades, they probably remember Subaru a little bit easier than remembering the name Pleiades, I'll have to admit. Okay, now I told you there was another cool thing right below the Pleiades, and you can't see it here in this software very well, but that's all right. Just below here, we see an object that has this nice reddish color. It's not white or bluish the way those hot, bright, and actually pretty young stars are among the Seven Sisters. Plus, it's actually a lot closer to us. It's so close to us that when you point a telescope at this object, it actually shows you a disk. There it is. Let's get it really big here. Oh, wow. Yeah, that reddish color, you can really see it now. This is an object that has been the focus of a lot of interest lately, hasn't it? I think you folks had heard about a certain rover landing on the surface of this body only a week or so ago. This here is the red planet Mars. Now, why is it red? Yes, that's right, Ellie. Why is it red? It's because the surface is actually covered with a lot of rust, iron oxides, as a matter of fact. So it's got a very dry, rusty surface. And so that's what we're seeing right there. And yeah, you probably heard about how the Perseverance rover landed on the surface. Waylena devoted one of our Prairie Skies shows to that a few weeks back. And there's all sorts of cool things we're already learning about that trip. There's been some neat panoramas posted onto NASA's website and onto various social media. You might have heard the first sounds recorded by the Perseverance rover because they actually put a microphone on that mission. They actually had it also listen to it travel through space as well, as it took that 8-month journey to Mars. So I'm looking forward to seeing what they're going to find with that mission. The other cool thing is we're going to see in a couple of months that the rover is actually going to deploy a very small helicopter, almost kind of like a drone, and that's called Ingenuity, and it's going to take pictures as it flies above the surface. So that's going to be really wild. And I see Waylena has just shared a couple of those links I was talking about right there. Anyways, this winter, Mars has been up in the evening sky, very nice and noticeable. It's been moving into the constellation Taurus that you can see right there. And let's see here, I think that's about the right amount of sky right there. And you see that it is over in the western sky right now at about 8 p.m. But you still have plenty of opportunities to look for the red planet going into the spring over the course of the next few months. But it eventually will set right with the sun. So you will have some time where you won't be able to see it, coming up by summer. I would say that if you're wondering to yourself how you could tell Mars apart from all these other stars that you see in the night sky, one thing to do is to look for twinkling. Bright stars, you'll be able to notice their flickering brightness. They'll also even seemingly change in color. Planets and the moon and the sun actually do this too, but since they're so much closer to us, in fact, millions of times closer to us, they will not twinkle nearly as much. So if you see a bright object in the sky that doesn't seem to be twinkling the way that the other stars are doing, you're probably looking at a planet right there. So that doesn't just apply to Mars, that also applies to Jupiter or Saturn or Venus, or even if you can catch Mercury in the sky. Okay, now let's see here. Let's go to a really famous constellation just over to the left of Mars. All right, you can recognize it from its really noticeable belt of 3 bright stars right there. And then there are other bright stars surrounding it. One of those stars actually looks kind of reddish on the upper left here as well. And also right below that belt, there's also another really interesting object to look at in the sky. One thing I need to remember to do during these shows is showcase a few of these objects that look great when you look through binoculars. What you are seeing right here is a beautiful nebula. A nebula is an area in the sky where we see lots of gas and dust. And that gas and dust usually is being lit up by the stars around it. Sometimes the gas and dust is actually just scattering starlight. That's where you get the blues that you can see there. That's a reflection nebula. Or you might see the reds like you see in this image here. And that's where the gas is actually being heated up to the point that the atoms are actually being ionized. Electrons are being stripped away from that atom. And then when they recombine, they show off this light. That red light is coming from the fact that most of it is hydrogen. So here's a lovely nebula here. And this bright light in the very center, those are some extremely hot, really bright, really young stars. That's why when astronomers look at these nebulae, they think they look kind of like stellar nurseries in a way. Now, that nebula did look great just now in Stellarium, but I encourage you, even if you don't have a telescope, to try to look at that nebula that I'm talking about there, because you can see it without even using binoculars. You'll be able to see it in the night sky if you can see this constellation. And if you have binoculars, that'll make it a really nice treat. Okay, if you're curious about which constellation I'm looking at here, this is the constellation known as Orion. Okay, Orion is our hunter right there. Okay, so three stars right there, those form Orion's belt. That reddish star Betelgeuse forms his shoulder. And then over here on the right foot is another very bright star known as Rigel. Okay, because those 7 stars that make up the main portion of the constellation are so recognizable, this is one of the most famous constellations in the night sky. And people all over the world can see this, even in the southern hemisphere. Although in the southern hemisphere, they would see this as upside down from what we see it. Okay, and I love using Orion's belt to help me find various things in the sky. Notice that we can take Orion's belt, go over to the right, and it goes almost right to the Pleiades. So I tell my students that you can use Orion's belt to point to the Pleiades, just like how we use the Big Dipper to point to Polaris. There's a litter of clues. They're really helpful to help you remember these things. Okay. And remember, the Pleiades, they're also a really great binocular object to look at too. The other thing we can do with Orion's belt, you notice that there's a really bright star down into the left here. And this one, it is a star. It's going to twinkle a lot. You can take Orion's belt and you can go straight to this star. I say straight to this star because the name starts with an S. Its name is Sirius. Notice the constellation it's a part of. All right, you see that it is part of a big dog, and in Latin that name is Canis Major. What I really like is that when you connect the dots of the bright stars in this constellation, that kind of does look like a dog. So yeah, they did a pretty good job at choosing the bright stars there to represent a dog right there. Notice that it says the name is Canis Major. That tells you that we're probably going to see a Canis Minor here coming up pretty soon. So because Sirius is in Canis Major, that's why it's referred to as the dog star. And for you Harry Potter fans, that name Sirius probably perked up your ears, just like with the dogs, right? And in that situation, the reason why J.K. Rowling had actually chosen the name Sirius for that character was because, you know, she knew that that was going to turn into a dog. And as a matter of fact, lots of characters in those novels were actually named after stars and other constellations in the sky. So Sirius is just one example right there. All right. I told you that we were going to find a little dog as well. I mean, Orion can't go hunting with just one dog, right? Well, if we go up and to the left from Canis Major, we will find our little dog. It's right here. There's Procyon, the bright star in the constellation Canis Minor. With this one, look for yourself. Do you see that pattern of stars right there representing a little dog? Yeah, not really. If it's just 2 stars, I guess that helps it qualify as a little dog right there. But it's kind of a stretch, honestly. That's why in the planetarium, when we show this one, we often, instead of showing an actual dog, we usually show a hot dog. It's probably a little bit more appropriate. Okay. So those are a couple of the constellations that you will see up there in the south and in the western skies over the course of the next several evenings. Okay, we've been seeing them all through the winter. They're setting a little bit earlier now, but you'll still be able to see them throughout the spring as those months come up. Ooh, take a look at that. Do you see the moon over on the left side? Well, in my software, I've actually amplified its size, so it's hard to miss it. But let's head over and look at the moon as well. If you're curious about which constellation the moon is in, once I click on it, you're going to be able to see it really easily. But I want to show you one little trick that helps you remember the name of this constellation. You remember how we pointed to Polaris with these 2 stars in Ursa Major or in the Big Dipper, right? Well, let's now take these other 2 stars in the bowl, okay? And if we go like this, that's going to help us find our next constellation. And what we're doing here, instead of pointing to Polaris, we are going to leap to Leo. So the moon is actually in the constellation, oops, I went a little bit too big there, is in the constellation of the Lion, okay? So you can see the Lion right there. And there's a really bright star in the Lion that I'll point out right now, and its name is Regulus. And one clue that I offer to my students to help remember the name Regulus is because the word Regulus, it sounds like the word regal. And regal is a nice kingly term, right? It sounds like regent, okay? Um, and of course, when we think of lions, we always think of the movie The Lion King, right? So that's a good way to connect that there. The regal Lion King, and that's the brightest star in the constellation of the Lion. Now, the moon, you'll notice, is pretty full right now. Let's take a quick look at that while we are here. I'm going to turn off the distracting artwork for just a moment. Oh yeah, wow, that is a very full moon there, isn't it? If memory serves, I think the moon is going to be full tomorrow. Waylena, is that right? I'm putting
Tomorrow, that was my understanding. I
Okay.
haven't checked for the exact time, so tomorrow
Okay.
could be tonight. I haven't looked
Yeah.
at the exact time for it.
Yeah. When I was checking other things, I think I had found that it was going to be full tomorrow. But I tell you, if you were to say that the moon was full tonight, that would be a pretty accurate thing to say. But yeah, that's the moon and how it will look when it's full right there. And while we're taking a nice close look at this, I think that let me just go ahead and cover a couple of things here. You'll notice when you look at the moon, if you're able to look at through a telescope, you're going to be able to see lots of interesting features. I have to say though, when astronomers are looking at the moon, they tend not to look at the moon when it's full. The moon shows off a lot more details when the moon is actually a crescent, or the first quarter when you can see half of the moon, or even at least just a slight gibbous. The reason why those are better is because the sun's altitude, the sun's lower in the sky when you're looking from the moon. So you can actually see lots of shadows over the moon. So you can actually see the three-dimensional features there. You can see mountains, you can see the shadows going into the craters. So you can get a real sense of the height, the elevation on the surface. So everything kind of gets a little washed out when the sun is directly overhead on the moon. But in this image here, we can show you lots of other cool things. You can see those tiny little craters there. When you look at the moon here too, you're probably seeing all those neat dark features on the surface. When people see those up in the sky when they're not using binoculars or a telescope, they think they're looking at the moon's craters, and that's not exactly the right way to put it with those things. Those areas are round because they were craters, but they were craters billions of years ago. The reason why these areas are dark gray is because those extremely deep impacts happened while the moon still was geologically active, while the moon still had flowing molten lava. Well, actually the right word is magma underneath the crust. And that magma was able to erupt to the surface as lava, and it actually filled in those craters. So those gray areas that you see there are those are now cooled lava basins that you're seeing. And those areas have far fewer craters than the other parts of the moon. They're also a lot lower in elevation. So astronomers, when they look at those parts of the moon, they refer to them as lunar seas or maria. Okay, so those gray areas on the moon, you're looking at the lunar seas or the maria. There's one of those that's probably more famous than the others. The very first moon landing that occurred way back in 1969, the Apollo 11 mission, had occurred in the Sea of Tranquility. Okay, and so these two seas that you see here are Tranquility and Serenity. And I have to unfortunately say, I just got completely put on the spot by myself, and I don't remember which one is Tranquility and which one's Serenity. Waylena, can you help fill me in on that one? Is the one next to Mare Imbrium Tranquility and the one that's a little farther south Serenity, or do I have that backwards?
I caught the same disease all of a sudden because
I know.
And Jeff is not in the room with me because he
feel
totally
so
knows
embarrassed.
all of the craters.
I feel so embarrassed. Let me see if I can pull it up right now. I wonder if this is on here. There's in Stellarium, there's occasionally some features that actually are listed on the surface. but it looks like they aren't being shown for the moon. I can do it usually with Mars and click on certain features. Ha, I can get craters. Hey, there it is. I knew I could do it. Perfect. Okay, so the farther north one is the Sea of Serenity. This one is Sea of Tranquility, although I'm not able to get it. I promise you, I've got it right.
Boy,
It's a Sea of
that's closing
Tranquility.
in. That's closing in, isn't
Yeah,
it?
yeah, that ain't fun.
Hey, Eric,
Yeah.
in the chat, someone
Yeah.
asked, when can we see the red moon?
That's a
And
wonderful question.
So yeah, if you mean the
Yeah.
lunar eclipse.
Yeah, yeah. So the moon can look red in a couple of different ways. The easy way, but it's also a very rare moment, is if you catch the moon right when it's rising. Okay, if you catch the moon right at the moment of moonrise, the moon is going to have its light passing through the thickest part of our atmosphere. And the reason why it's thick is just because the moon's barely above the horizon, so it's at a very skewed angle. And when it's there, it's just like what happens when you see sunsets. Remember how the sun looks kind of red at sunset? The moon does the exact same thing. If you don't mind, I think, what can I do with this? I bet if I go back here, I think that I'll try this. I'm going to try it. I bet you this is not going to look quite right because of the sun coming back up in a moment. All right, let's do this. I wanted to do it and I had to pay the price. Okay, the reason why the moon now looks like an egg is because the moon is just below the horizon. This is trying to give you a sense of how much our atmosphere can distort things. Remember how I was telling you about twinkling? This is how our atmosphere can affect the moon. If you see the moon right when it's rising and you put it through a telescope, you'll be able to see that sort of twinkling happening in the moon. The edge of the moon actually looks like it's churning. I love looking at the moon right when it rises. Okay, so notice that the moon, as it gets closer to the horizon, there, it's getting real flat. Oh, it's so funny. I'm glad I'm showing you folks something as goofy as this.
There you go.
But
Awesome.
but the moon looks very orange, just like what happens with the sun when it's setting. Okay, and so you can see this during any time, any phase of the moon. When the moon is rising like this, you can see it looking nice and orange like that. I'm going to cheat and I'm going to go a couple of days into the future. I hit the wrong button. All right. Okay, there we go. We're going to go, there's our egg again. I went way too far. All right. Okay. Need to see where I'm at now. I've kind of lost my position. So
you can also see it look red sometimes when there's been a lot of forest fires too.
Oh yeah. If there's
that's an icky kind though.
Yeah. If there's lots of dust or smoke in the atmosphere, this will happen there too. The reason why I'm going to mention this is just because 2 nights from now, the moon, when it's now a waning gibbous, if you see the moon then an hour or so after sunset, you can catch the moon rising at that time, and that's a great time to check it. I always love seeing that gibbous moon rising after sunset because you can catch it because you'll see it brightly in the sky and the sun's not up anymore, and those are great times to see the moon looking like this. Now, the more famous red moon is the one you were probably thinking about, and the one Waylena mentioned a few minutes ago, and that's during a lunar eclipse. Okay, so if you have a pen or, well, your phone, I'm going to have you folks make the note of the following date. Mark this in your calendars, folks. 2022, May 15th. Okay, we are not going to see a lunar eclipse here in Champaign until, there's that egg again, until the end of May 15th. It might actually, yeah, I think it's on May 15th. I hope I'm actually not on the day ahead of it, but I might be. On May 15th, the moon is going to fall into Earth's shadow. Okay. Oh, there you can kind of see it a little bit right now. Here, you might not be able to see it from your ends, but I went way too early, didn't I? I was trying to do 2 things at once and I got myself a little embarrassed.
Now, if you're in Hawaii, then you'll be able to see one in a couple of months.
Good point. Thank you for the reminder. I'm really talking about how in Champaign this will be your chance. Thank you very much for that clarification.
But if you need an excuse to go to Hawaii.
I think farther west, they'll see almost
They'll see part.
Right before sunrise. Is that right? And that's also in May, isn't it?
Yes.
Okay.
Yes. That's May 26th, I think it is.
Yeah.
Yes.
So for anybody who doesn't want to travel for a lunar eclipse, and usually I don't do this because lunar eclipses are visible to half of the planet. What you're seeing now, notice this little arc passing over the moon right now. That is the moon moving behind Earth's shadow. Okay, it is being recorded. That's right. Well, there, I already said it out loud. All right. I just happened to see it pop up. So yeah, if you're curious about the time, I'll do this just because it's easier for you all to see. After 10 p.m. Central Daylight Time on May 15th, you're going to see the moon pass into Earth's shadow. And once it gets in there all the way, you'll start to see it take this nice bloody hue. Okay, so sometimes people like to call these blood moons. That's fine, but it is a lunar eclipse. The reason why the moon here happens to look, there's another feature. The reason why the moon happens to look red is because even though the moon's completely inside of Earth's shadow, meaning it's not getting direct sunlight, some of that sunlight still is being bent as it goes through Earth's atmosphere. It refracts, and that red light does the best job at getting over and illuminating the moon in that fashion. So the poetic way I love to describe why we see the moon looking like this is because the moon is being lit up by all of Earth's sunrises and sunsets. Okay, that's what you're seeing right there. All right. So yeah, that's going to happen in May of next year. Hopefully you've all now marked your calendars. Let's head back to today now. All right. I'm going to keep focused on Flammarian U because everybody loves that one. That was a joke. And I'm going to zoom back out here. All right. How are we doing? Okay. So yeah, I believe, we had the moon in the constellation Leo, and the moon is coming up right at sunset, and it's going to be up all night tonight. The moon is full because the moon is in the opposite place in the sky as the sun. So the moon tonight is basically coming up right at sunset, and it'll set right at sunrise. All right, so that'll be a cool thing to keep track of. But I think we've investigated enough of the moon over the last couple of minutes, so I'm going to go ahead and go a little bit later into the evening. I'll bring back our ground once again as well. All right, and I'm going to turn off our cardinal directions because that doesn't look as fun to look at. All right, so as we go later and later here, we see a number of other features. I was showing you a couple of bright objects over in the spring sky. You already saw Leo. I'm going to show you another fun one that we love to share when we're looking at the spring sky. Here's the Big Dipper. The Big Dipper is now much higher than it was before. And then right here, you can see the handle of the Big Dipper. And we've already seen how it's not a straight handle. It's kind of curved, like a circular arc. And so what we always like to say is that we follow the arc to Arcturus. Okay, so it's another good mnemonic device to help you remember that. You follow the arc to Arcturus. All right, and now I'm going to actually ask Waylena for her opinion on how she says the name to the next star. There was actually a robust debate among planetarians, people who work in planetariums, on which way they prefer to say this. So if you're going to the next star, Waylena, what do you say?
I say spike to spica.
You say spike to spica. So you arc to Arcturus and then you spike to spica.
Yeah.
And
but
Spica's
you
right.
do you. If you want to, if you want to.
I usually say spike to spica there, but I do not mind if you want to say speed on to spica. If you prefer to pronounce it spica, you do you, as Waylena just said. Okay, there you go. Yes, we're back on solid ground, Ellie. That's right. Okay, so those are a couple of really bright stars over in this part of the sky, which we call the spring sky. The reason why we refer to certain stars or constellations as winter constellations or spring constellations is going back to what I was just talking about with the full moon. It's based on where they're at in the sky relative to the sun. During our winter months, the winter constellations are in the opposite part of the sky. So they're actually going to rise right at sunset and they'll set at sunrise. And you can see them all throughout the night. Okay, and so these spring constellations or spring stars, they're in the opposite part of the sky from the sun during the spring months. Okay, so that's why we're seeing them a little bit later. This is actually the sky at about 11:22 p.m. Okay, that's what you're seeing here. I'm actually going to keep that time up there because I think this might help a couple of you folks as we're going later into the evening. All right. This is probably past most of your bedtimes, but if you're looking to pull an all-nighter, this is what you'll see going into the night. You probably won't see it moving this fast. We're going pretty quickly here. This is actually at about 2 a.m. All right. So now, by this moment, at about 2:17 a.m., I'm going to get to addressing Waylena's excitement at the moment. I promised that was going to happen. Take a look back over here in the west. You'll notice that our Canis Major is actually only setting right now, okay? So Orion's actually already below the horizon at about 2:17 a.m. And then you can see a couple of other stars. That's where Spica is. That's where Arcturus is. They're very high up. And Waylena is getting extremely excited about one of the stars that's just starting to rise.
It's back, it's back.
That's right. This constellation, I want to actually focus on it after it all the way gets up. It's really hard for this constellation to get all the way above the horizon around here because it's so far south. It's a much easier constellation to see if you live in the southern hemisphere. This constellation, you'll notice that there are two stars right here, and you kind of curl up like this, and it kind of looks like a fish hook. And we always bring that up, especially nowadays, because this constellation had a starring role in the movie Moana. Okay, and you remember Moana actually had a lot of assistance from a certain demigod named Maui. All right, and he was always carrying around a hook. The point is, the Polynesians see this constellation as Maui's fish hook. But you'll notice here that when we look at the Greek and Roman name for it, they refer to it as Scorpius, because they see a big scorpion up there in the sky. Certainly, yeah, it definitely could look like a cat's tail. I do not disagree.
I agree with Ellie. It looks like a cat's tail for sure.
Yeah, that works. And it's, you know, when you don't really have, you only have a couple of cat constellations up there. I mean, we have Lynx and Leo, the big cat, right? Do we have any other cat constellations behind those two?
Well, there is Leo Minor.
Oh, yes, Leo Minor. That's true. Yeah. If you folks want to see that other cat, Leo Minor is actually between Leo and Ursa Major. I think it's right here. Ooh, did I get that right? No, it didn't pop up anything. Ah, that's why. Okay. Yeah. So there's your baby cat. Oh, look at that. Look at that lion cub. All right. Is it a lion cub or is it a lion kit? I don't remember. You are absolutely right about not really seeing a scorpion with this one. The reason why it looks like a bit of a stretch after considering the stinger of the scorpion is because this constellation has changed dramatically in how we see it nowadays. We've got the body of the scorpion actually represented by these three stars, as well as this brightest star, which I promise, Waylena, I'm going to get to it. But the pincers, or oh gosh, I keep forgetting to look up this word. It might be chelidae or something like that. But the actual, claws that you normally see for the scorpion are actually represented by these two stars up here over in the constellation of Libra. So Scorpius is accidentally trying to take over the constellation Libra. All right. In a way, and they kind of pushed back on that and didn't allow it. However, these two stars still have retained their names based off of being the claw stars of the scorpion. In Arabic, the names of these two stars, they were actually transliterated, and it's what the common name for these stars are. This one is Zubin al-Shamali, and this one is Zubin al-Janubi. And if somebody in our audience knows more Arabic than I do, feel free to correct me on that pronunciation. But that's the way that astronomers and planetarians usually say it. But yeah, this here is our northern claw star, and this here is our southern claw star. Okay, so we've got the Scorpion's tail, its body, and the northern and southern claw stars. I think Waylena is probably quite shocked that I've given the name of those two stars before I've given the name of her favorite star.
Not at all. Zubin al-Shamali and Zubin al-Janubi. They're awesome.
They're classics. Now, this star right here, the star that often we refer to as the heart of the Scorpion, since Scorpius is a constellation that's in the zodiac, that means it's visited by all sorts of objects in our solar system. That is because it lies very close to what we call the ecliptic. The ecliptic is the path that the sun takes through the sky, and that path takes it through all of the zodiac constellations. And in addition to the sun passing along the ecliptic, the moon passes very close to the ecliptic. That's why you found the moon in Leo. And also the planets actually move along close to the ecliptic as well. And one of those planets is that red planet that I showed you earlier tonight, Mars. Well, this star right here is big and it's red, and some people might potentially mistake it for Mars. And its name comes from being held in comparison to Mars. Its name is Antares. And remember, Ares is the Greek name for the god of war, and Mars is the Roman name for the god of war. So you could imagine to yourself that Antares was basically just named, not Mars. So if you want to be a bit of a smart aleck, you could go and tell somebody when they ask you what the name of that star is, they could be like, oh yeah, that's not Mars. And they'd be like, thanks a lot. Thanks a lot. I'm glad you told me what it's not. That's real nice. Well,
but it totally does look like Mars when you see it in the sky.
Definitely, definitely. In several months, the Mars will actually be next to Antares once again, and I encourage you to check that out. I don't remember exactly what time, but that will happen it happens about once every 2 years, so it will happen again. All right. The last objects I'm going to show you now are what are coming up right before dawn. Let me go ahead and turn off all that fun stuff that I've been sharing. Oops, and I turned on another thing. All right, so it's already at about 5 a.m. now, and the last thing we're gonna see are a couple of planets. All right, ooh, look at that. Bright objects right over here coming up right before sunrise. I don't know if they're gonna be bright enough to catch right before sunrise, but if you're up at that time, feel free to look over in the just south of east and check them out. Okay, the first one of these is a lovely planet that everybody likes to look at. I'm going to focus on it right now, and I'm going to show you what it looks like, because I tell you, when it comes to looking at this thing through a telescope, it's probably my favorite. And there's lots of beautiful pictures of it too. You folks know which one this is? Yeah, this is the planet Saturn right there. And you knew it because of those beautiful, beautiful rings, okay? And I tell you, when you point a telescope at this, you can actually see those rings there. We've had lots of people tell us when they see this for the first time in their lives, they think they're looking at some sort of sticker on the eyepiece. Yeah, those rings are just gorgeous to look at. So whenever you get a chance to look at Saturn through a telescope, take it. That's what I have to encourage to you. Now, the next one here, because I'm not sure how far apart they are now. Gosh, I don't remember. Oh man. Well, guess what? We're going to have to. We are going to discover together. We're going to discover together, and I'm going to cheat and not let it give away. I'm going to click on it. I'm going to center on it, and I'm going to zoom in. I will tell you, folks, we are looking at either Jupiter or Venus, and I bet this is Jupiter because it's not as bright as Venus. That's my guess. Let's find out.
Yes.
Even worse. Love it. Love it. I knew I'd be wrong. Awesome.
Even worse. Yes. Wow.
Folks, that's okay. I knew I couldn't remember how close it had been. I thought it zipped around and I thought it was gone. Folks, I'm glad this moment here has been recorded for
Yes.
posterity because
Oh, I
we are
wish it weren't
looking
gonna
at
be
the planet
cloudy.
Mercury. Hmm?
Yeah, it's a shame it's gonna be cloudy.
Yeah.
I set the alarm for that because we don't
Yeah.
get to see it very often. It's a sneaky planet.
That's right. So this is the planet Mercury. The way that you can tell you're looking at Mercury right here is because you can actually see the craters on the surface in Stellarium, and you can see that it's showing phases just like the moon does. Both Mercury and Venus show phases, but Venus is covered in clouds, so you can't see surface features on it from any Earth-based telescope. Mercury is also pretty darn hard because it's always so close to the sun. And goodness, has Venus actually, did Venus already go through its conjunction? Is it actually on the other side of the sun yet? Probably not. All right, is this Jupiter? Let's find out. You know how Jupiter and Saturn had their conjunction back in December. I didn't know how far Jupiter had gotten from Saturn, and I'm not up this early usually, so it's not something I am remembering much lately. Oh yeah, that makes it so obvious. So one way you can tell this is Jupiter, look at those 4 moons around it in a nice straight line. And then when you get up close to it, I love looking at the cloud bands on Jupiter, what we call its belts and zones right there. I'm going to do one thing to make this easier to look at. That's when we take away the atmosphere and we get that amazing shot of it. Stellarium has a nice rendered image of Jupiter up there, and we've sent lots of missions to this planet, and there are amazing photos that we're getting all the time, including currently from the Juno spacecraft. The Juno spacecraft has this amazing orbit going above the poles of Jupiter, so it's giving us images of parts of the planet's clouds that we've never really seen in this angle before. So it's giving us some wonderful perspectives that we have been missing. All right, probably should put that back on. Okay. All right. So after that embarrassment, I bet you Venus is still coming up. We'll find out. It could be wrong. Maybe Venus is actually coming up right next to the sun is. Oh, thank you for sharing the Juno link. That's good. All right. And I'm going to turn this off. By this point, you probably wouldn't be able to see any planets. To make things look a little easier for all of you on Zoom here, when I set up my, when I have Stellarium set up here, we enhance the brightness of everything just so that you don't lose some of this stuff if I've got a poor feed in the meeting. So that makes things probably a lot brighter than you'd actually see them. Perhaps you'd see Jupiter at this moment, which is at 6:13 a.m. But I bet if you didn't see it, I wouldn't be surprised. Okay. So yeah, look at this. It's still trying to show us stuff like, oh my gosh, at this hour, are we probably looking at Arcturus right there? No, that's way too low.
Oh, that's
No.
Antares.
Yeah, yes, that's Antares. No, I see it now. It's just getting too dark. There's Arcturus. Okay. Yeah. Sorry. Wow, Antares actually looked a little high for me. That was why. All right. Making lots of mistakes tonight. It's a good thing this is being recorded. All right. And now even Jupiter is gone. And that tells me that by sunrise tomorrow, yeah, looks like we're not going to be able to see Venus at all. So just because I kept promising Venus, I'll show it to you after the sun comes up.
Planetarium magic.
That's right. Through the magic of taking away the ground, okay, you'll start
Tell you
floating
though,
now.
don't feel bad about Mercury as a mistake, and to everybody else, you know, you get so used to not being able to see it, and then it'll sneak up on you, and you'll have it there for a week, and then it's gone again because its orbit just goes so fast.
Yeah.
So Mercury and that, what just happened to us there with Stellarium being surprised that Mercury was there, that happens for real in the real sky.
Yep. So here's me taking away the atmosphere. I forgot to tell you to hold your breath. Hopefully you'll forgive me. You'll notice that there's something really bright just to the right of the sun, okay? And that, let's click it and hope, Venus. So Venus is getting so close to the sun that you're not going to really even see it even before sunrise, because look at this. It came up basically right next to the sun. Look at that, only like 5 to 10 minutes beforehand. It's just at the wrong angle. In a couple of months, Venus is actually going to get behind the sun and start coming up before sunset. But because of the bad angles involved there too, you're not going to see Venus until much later this year. Okay, Venus will eventually assume its role as an evening star, as in the first object you see after sunset, but you're not going to see that nice and prominently until much later this year. Okay, all right. So folks, you have been up all night with me looking at lovely clear skies. So hopefully you're willing to go back and enjoy those cloudy, warmer at least, evenings that we've got planned for us in the weather forecast for the next couple of days. Please go ahead and share any questions you might have in the chat. And if you can't actually type in the chat and you feel a lot more comfortable using your microphone, feel free to make a request for that. And we'll be happy to allow you to unmute yourselves.
And a quick plug, next week we'll have our Keller Science Lecture talk is going to be a presentation on a variety of birds of Central Illinois. There's a lot of birds that you might not realize are in the area. And the speaker is actually my husband, Jeff. We met in the planetarium, and he's developed this amazing bird photography hobby. Afterwards, now it means staying up a little bit later, but afterwards we'll have a Prairie Skies special spotlight on extrasolar planets. So planets around other stars. So that's going to be a lot of fun, and we'll record that too.
Okay.
All right.
Ellie, you asked a question just now into the question Q&A, and I think Waylena answered that in the chat. So I'll just go ahead and say it out loud so that everybody can hear it this time. The names of the moons of Jupiter are in order going away from Jupiter: Io, Europa, Ganymede, and Callisto. Here's a wild little fun fact for you with this regarding Io. Io is roughly about the same size as the moon, and it's also at roughly the same orbital distance from Jupiter as the moon is from Earth. But the funny thing is, Io doesn't take 29.5 days to make a complete orbit around Earth. Well, because it goes around Jupiter, it takes less than 2 days to orbit around Jupiter. And the reason why is because Jupiter has over 300 times Earth's mass. So its gravitational pull is extremely strong, and so it zips it around the planet a lot. Plus, that gravitational pull causes some really strong tidal forces, and that's why Io is still actually volcanically active. Io actually has hundreds of active volcanoes that are actually reshaping the surface right now.
So how does that how fast does Jupiter itself spin?
Jupiter's spin, it depends on which way you want to define it first, but the general way that they define its spin, I think they did this based off of looking at how quickly its magnetic field rotates. And they found that its rotation rate is just under 10 hours. Okay. So it's a lot
fast.
Yeah, it's a lot. Even though it's so much bigger than Earth, it's actually got about 10 times Earth's radius. So it's about 1,000 times Earth's volume. It zips around very quickly in only about 10 hours. So the cool thing you can look at, if you were actually to point a telescope at Jupiter over the course of an entire night, or you can simulate this on Stellarium, you'll see it rotate pretty quickly. So if you're looking at it and you want to see like the Great Red Spot, the most famous feature on Jupiter's clouds, and you don't see it now, well, wait a few hours, it might show up. Okay. Now, great question about the planetarium having telescopes available to rent or borrow. Yeah, if you are interested in renting telescopes, we can schedule a time for you to come to the lobby and pick up one of those telescopes. We have Dobsonian telescopes. They're actually pretty big. Is the mirror about 8 inches or 11 inches? Is it 11 inches?
8 inches, I think, yeah.
Okay. Humongous telescopes, and we show you how to use them, and you can rent them for a night or for a weekend. We usually charge $10 for the night or $15 for the weekend. And we can schedule something in advance so that you just come to campus and meet us, and we can set that up for you. Oh, I forgot to put the send in there. There we go. All right. Yeah. I don't want to mess with my green screen, but there's, you know, one of those telescopes is only a few feet away from me. I think I'd probably knock over the green screen before I actually get it set and put it in view.
Yeah, I had a picture I was going to put in the background, but it's not as handy.
Excellent point. It's almost as if I've got a website up that would show it. All right. So I'm going to go back to sharing screen here, folks. Let's go with this one. And I don't need to share sound and optimize screen sharing, so let's do this. Hopefully, Waylena, do you see the resources page of the website?
I do.
Okay, so under educational resources, folks, I'm going to make this a little bigger for you all to see. Telescope rental. And you can see what our Dobsonian looks like right there. Okay, so that is our Dobsonian. We've got 4 of them actually that we check out to the public. And you can see some other specs of it. That doesn't show you how big it is compared to a person. I don't have one picture that shows you how big it looks like to a person, but I've gotten it to fit into a Honda Civic. I had to take the tube off of the mount, but it still fit. So that it's, you know, it's a little challenge like that, but it can fit into most vehicles. Don't come here in a Mini Cooper. That's what I would say. All right. And if I want to share with you another thing, I actually wrote an article in the News Gazette several months ago that they gave me a full page on it right there. So you can see a lot of that same information about getting a telescope right there. I should give that article to my mother, who's actually on this call, and so she can put it up on the refrigerator.
Aww.
All right, folks, do you have any other questions for us?
All right. Well, we put in the chat the our YouTube channel, so the recording made from this, we will put that up on the YouTube channel, and also check out some of the videos that Erik and I made this month to celebrate the celebrate Mars and the Mars landing. So we've had some fun with that. So hope you all check it out. Make sure to like and subscribe.
Yeah, all right. And of course, we hope you can join us again next week for the James B. Keller Science Lecture Series. If you like seeing birds, you're going to love this show because Jeff is a great birder and he has got some amazing photographs to share with you all. Okay. I think you're going to enjoy this, and I think we're going to have a big audience for it. And to answer the last question that I see in the chat here, not the one in the Q&A, that date, 2022-5/15, that is the next lunar eclipse that will be visible in Champaign. Okay, there are other lunar eclipses that will happen in other parts of the world, but that's the next one that'll be visible around here. If you want to know where you can find other lunar eclipses, there are lots of websites out there that will tell you when the next eclipses occur. NASA actually maintains one that I check pretty often as well. In fact,
I have it coming. Yeah.
Okay.
I had it up earlier.
yeah, that's all good. So I can just share the screen because we're still going here. It's all good. Did I get it up correctly? All right. So NASA has this website right here, eclipse.gsfc.nasa.gov. GSFC, Goddard Space Flight Center. You can see right here the last total solar eclipse that had occurred. Actually, the path of totality went through South America. But in addition to that, you can look at lunar eclipses as well. Right there, 2021 through 2030. You can see all the lunar eclipses that are predicted to happen over the course of this decade. Okay, and as I just said, 2022, it says May 16th here because for Greenwich Mean Time, it's happening after midnight. And I believe you folks were talking about the one in Hawaii, right? That one will happen on May 26th. Okay, so for people who really, really want to travel, which folks, pandemic, that is happening. Oh, you said Hawaii. Oh, yeah, that's right. So yeah, so that one is visible in Hawaii, and a little bit of it will be visible in the western part of our country. Okay, yeah, the weird thing about this diagram here is you see the dark area, and that dark area, you can't see the eclipse because it's daytime. It's really, really kind of backwards. All right. Okay. Any other questions, folks? All right, folks, have a good night. Thank you for joining us. And we hope to see you again at the next Prairie Skies show and at the next Keller lecture.